All right, we're going to do the Pythagorean theorem. Told you earlier we learned the Pythagorean theorem before. We've had to use it before. This is the first time they're going to actually prove it. Does anybody remember why it's called the Pythagorean theorem? It's named after a person, Pythagoras, right? So this is how you spell it, Pythagoras. And let's see, I looked him up, and he lived from 570 to 495. Now, going the wrong way, right? So what? It's BC, right? So it's 500 years before Christ. Okay, this guy Pythagoras was around. I did a little research on him last night, and he was a pretty interesting character. He even some videos even said like
Those videos back there? So, how else do you have a big one?
All right, I'm not going to talk about Pythagoras now. I could just assign the homework and just expect you to do it and give you a quiz on it tomorrow without going over it. Is that what you would like to do? Braden? Don't just yell things out. I'm trying to get everybody settled down, and you're yelling something out. You ready to pay attention now?
What did I do?
See, that's like a little child right there. That's a child's response. Be an adult, okay? Let's try this again. I'm going to skip the Pythagoras stuff. You apparently guys aren't listening today anyway, so you got me in a bad mood. So I was in a good mood like 15 minutes ago. All right, let's try this again. Can't even believe I'm recording this. All right, so here it is. Pythagorean theorem is a squared plus b squared equals c squared. All right, you've seen that before. All right, this can only be used with right triangles. Okay, the A and the B represent the legs of the right triangle, and the C represents the hypotenuse of the right triangle. Oops, can't spell. All right, so you know about that. I don't even feel like doing this now. So what we're going to do is we're going to make a triangle. And I just want to just do it. All right, so I'm going to draw a triangle. I'm going to do something with this. This is nothing that you're going to have to like do on the homework or anything like that. I probably wouldn't even do this for a CP class. Of course, today I feel like I'm teaching CP class the way you guys are acting, but let's group that together. Okay, let's see what I want to do here. So I've made a right triangle, so this is definitely a right triangle. I don't really care how long this side or this side is. Okay, this is the hypotenuse, this is one leg, this is another leg. We're going to label it in a minute after I draw this thing. So I actually practiced doing this last night, see if I can do it today. So I'm going to copy that, I'm going to paste it, and then what I'm going to do is I'm going to rotate it. What we're going to do is we're actually going to make, using these we're going to make 4 triangles. And what I'm going to do is make a square inscribed in another square. I'll show you what I'm talking about in a second. So let's just think if I go like that, it should work. Yep. All right, now watch what I'm going to do. I'm going to take this triangle, if I can grab it, I'm going to put it right here, like so, okay? Now I'm going to take that, actually, let's do this. Let's get rid of that one. No, I guess I can keep that one we had before. Let's see if this works. So just be patient. I'm going to do this a couple more times. I'm going to rotate. Instead of 90, I'm going to go 180. Okay, like this. Oops. All right, that's pretty good. And then I'm going to rotate this 270 degrees. 270. There we go. Now watch what I get. So, yeah, but it's not just any quadrilateral. All right. But do we know for a fact that it's a square?
No.
Well, we do know this, though. Remember I said I started off with a right triangle? So I do know that the big one on the outside is a square. Why do I know that? Because I made this triangle, and I made it a right triangle, okay? I specifically made it a right triangle. Came down here, made this a right triangle, this one, and this one. So I do know that the first one's a square. Do I know that this is a square? Sure looks like it, but how do I know it's a perfect square? Well, I'm glad you asked. So let's put some letters in here. I'll tell you what, let's do this first. Let's take this first triangle that I drew. See this triangle right here? That's the first one I drew. Let's call that side A, and let's call that side B. Very good on that? So this triangle right here, I copied and pasted. So A is my shorter side. So look at this triangle right here. Which one is my shorter side? Is it the one on the top or the one on the right? The one on the right. That's the shorter side. That was A. Then the longer side was B. Everybody got that? Let's continue to do this. So this is going to be what? That's going to be A. That's the shorter one. This is the longer one. Is it off the screen? All right. Let me... Okay, there we go. All right, so this is A, and this is B. This one is A, and this is B. Everybody got that? Okay. This is the hypotenuse to these right triangles. So what do you think I'm going to call this one right here? Let's call it C. All right. So we'll call that C, call that C, that one, and that one. All right. Now what I'm going to do, let's go a different color. What I want to do is I want to see if this is a square or not. Now, there's a reason for doing all this stuff. Nate, you getting all this, right? So there's a reason that I want to find this to be a square. So I got to find out. It looks like a square. You could just say, well, sure, it looks like a square, so I'll say it's a square. But you can't say it's a square 100%. I don't know exactly that that's 90 degrees just yet. But I'm going to show you how we can figure out that that's 90 degrees. Okay? So that's what we're going to do. So let's do this first before we figure out why this is 90 degrees right here. And it is a square, I'll tell you right now. But we don't know right now until we do a few things. So let's do this. Let's call this angle X. Let's call this angle Y. All right, I'll show you why in a second. Everybody with me on that? I just named it whatever. You can name it any letter. I just use X and Y. So this angle is X and this is Y. So what I'm going to do is just look at this top triangle. Since I put an X here and a Y here, I could do the same thing with all the other ones. I could have made this a Y, this an X. So the little skinny angle is the Y, and the one that's a little bit bigger is the X. I guess I am doing it all. So you could do that if you want to. You know what I'm talking? I'm talking about the angles. Agree? I'm not writing the little arcs in there because I already got enough stuff in here. I'm just going to put the letters. Everybody with me so far? So look at this. You can use any of these four triangles, doesn't matter. But let's just take a look at this triangle right up here. What can I say about the angles of this right triangle up here at the top? They add up to 180. Okay, so let's write a little formula for that. Okay, so what are my three angles? Angle what?
Y, X, and...
Yeah, so X and Y. So I'm not going to put the angle symbol just to make this a little easier for us, okay? Without having all that stuff written all over the place. So I've got angle X plus what? Angle Y plus what?
I said it C.
No, not C. We're talking angles. C is a side. We're not talking sides.
Well, I didn't know what we were calling it.
Just call it, how many degrees is it?
90.
It's 90 degrees. So let's call it what? 90. So those three angles, angle X, angle Y, and this 90 degree angle, what do they all add up to be? 180. Okay. Now let's do this. Let's get rid of the 90 and put it on the other side. So we would end up with what? X plus Y equals 90. Okay. Everybody with me on that? So now check this out. Do you see this X right here and this Y down here? So if this X plus this Y is 90 degrees, what's that whole big angle right there? It's 180. So, okay, so if this x plus y is 90 degrees, so I would take 180 minus what? The x and the y, right? Minus x plus y, which is what? 90, isn't it? So 180 minus 90 is what? Is 90. So what's this angle right here then? On my notes, I called it Z, but it doesn't really matter that you call it anything. But now we could say that that's 90 degrees. Does that make sense? Right? Again, this x plus y is 90, so what's left over? A 90. So what's this one? X plus y, that's a 90. This is x plus y, so that's what? It's 90. Right? So now we actually proved, we showed, I guess, that all four of those are 90 degrees. They're all C, right? Because they were all the hypotenuse, because I copied and pasted. Right, so what's true about this figure inside of the big square? What is it? It's a right square. It's just a square. It's just a square. It's just a square. You don't have to say it's a right square. That's redundant. Okay. All right. So, what are we trying to do anyway? We are trying, and we'll get to it in a second. Okay. It's a long way to go, but I think it's good for at least an honors class to see the proof of the Pythagorean theorem. By the way, there's more than one proof of the Pythagorean theorem. In fact, there's multiple proofs of the Pythagorean theorem. Do I know them all? I barely know this one, okay? So no, I don't know them all. But I did look it up a little bit, and there's tons and tons of proofs. When I was going to talk about Pythagoras, and I mentioned this before, I believe, Pythagoras did not come up with the Pythagorean theorem. You would think he would, Sam. You would think he would have come up with the Pythagorean theorem since they gave him the name, right? Wouldn't you agree? All right, but he didn't. Does anybody remember? I mentioned this earlier in the year. Why did they give him the name when he didn't come up with it? They actually knew. I read somewhere they said probably at least 1,000 years before Pythagoras. Okay, so where does that put us in history? Like 1500 BC? At least. And they're saying it could even go back even further than that people knew about the Pythagorean theorem, right? They didn't call it the Pythagorean theorem, obviously, because he proved it, exactly right, okay? So Pythagoras is given this name because he was, I don't know if he was the first one, but he's the one that made it known, right, that people knew the proof of the Pythagorean theorem, which is kind of interesting, I think. So I'm just going to get rid of all this just so I have some more room to write, okay? So what are we trying to do? We're trying to show that a squared plus b squared equals c squared. That's what we're trying to get to, all right? Well, I've got an a, got a b, got a c, right? And I know I've got right angles, so I want to figure out why a squared plus b squared equals c squared. All right, so now we're ready to do this. What we're going to do is we're actually going to use areas. Remember we just finished doing a chapter on areas? So let's find the area of I'll call it B for the big square. Is that all right? Okay, so the area of the big square. So what is area of a square, by the way?
Base times height.
It's just length times width or base times height. Okay, either one's the same exact thing. All right, so let's look at the big square. That's what the B stands for. So A is for area of the big square. So what are the sides? What are the lengths of the sides of this big square? The lengths of the sides. 90 would be an angle. Okay, it's not a squared plus b squared. A plus b is one side. Would you agree? So what's the length of this side from here to here? It's not AB, because AB would be a times b. It'd be, because what if this was 3 and this was 4? The whole thing would be what? 7. So you wouldn't go 3 times 4, would you? You go 3 plus 4. So it's a plus b. That's one of the sides. Okay, the length or the width, whatever you want to call it. Or the sides. Remember we did a formula. The area of a square is the side squared. Remember that? All right, so this is one of the sides. What's the other side? This side right here. It's the same exact thing, isn't it? So that's a plus b. Now, we're going to do a little bit of algebra that you should have done in Algebra 1. Again, when you do math, sometimes you have to work on the assumption that you knew stuff from before, all right? If you didn't, I think we might have mentioned this on Thursday. We might have done a little bit of this on Thursday. And we're going to do another, actually, no, not right now. All right, let's do this. We should know how to do this. When you have two binomials, remember that word from Algebra 1? When you have two binomials multiplied together, we use a method, and all the letters stand for a word. Do you remember what that's called?
Foil.
FOIL method, okay? So use the FOIL method. Everybody remembers that, right? Remember? Yeah, sure you do. If you don't, you were just sleeping, because I know for a fact that you taught it. When you came here?
Yeah. For like 2 weeks.
You came here last year?
Yeah.
Oh, okay.
For like 2 weeks.
You didn't do it in your school last year? FOIL method? And you had Algebra 1?
Yeah.
And they didn't do FOIL method? Oh my gosh. All right. Because that's a pretty standard thing that they do in Algebra 1. Anyway, we're going to learn it now. All right? So now we're going to learn it. So if I multiply these together, I multiply the first, the outside, the inside, the last. That's FOIL. Okay? First, outside, inside, last. Got it? So I multiply the first ones. Which ones are the first ones? The A and the A. So what's A times A? A squared. Okay, now I do the outside ones. Which ones are the outside ones? Well, this one and this one. See how that's on the outside and that's on the outside? Right on the further, like this? Right, so what would that be? That would be AB, wouldn't it? So A times B or AB. Plus the inside. What's the inside going to be? You could say BA, but it'd be better to say what? AB, since that one's AB. Doesn't matter, does it? And then what's the last terms? B times B, which is B squared. All right, let's simplify it just a little bit more. We can add like terms. So if I add these two up, what do I get? No, it's not AB squared. I'm adding them together. What's 1 apple plus 1 apple?
2 apples.
2 apples. It's not apples squared, right? So what's 1AB plus 1AB?
2AB.
2AB.
2 bananas.
Okay. All right, so that is the area, and let's hold on to this. We're going to hang on to this for a second, okay? We're going to use this a little bit later, okay? So we got the area of the big square. What else do you think we're going to find? We found the area of the big square. What do you think?
The area of the small square.
Yeah, so let's find the area of the small square, okay? So I'll just put A sub S for the small, all right? Now that's actually very easy. It's a little bit easier than the big square. Why is that? Because remember, the area is the side square. What are the sides of that small square?
C.
It's C, so it's what? C
Where?
squared, right? It's C times C. Make sense? So I told you that one was easier, wasn't it? Right? So what I'm going to do is, I'll tell you what, let's put it in a box. I was hesitating to put it in a box, but let's do it. So I've got this little formula. I got this little formula. Now I can find the area of something else. Yes.
It says outside, you're talking about both these, or you're talking about...
No, it's talking about the ones, so the AB are the ones in the middle. Well, they're on the outside, but the ones in the middle are the inner ones, right? So these are the inner ones, and these right here are the outer ones. Okay. All right. What else do you think we can find? So we found the area of the big one. We found the area of the little one. What else is in here that we can find? The triangles, exactly. Now, how many triangles do we have?
4.
And I copied and pasted them. So what do you think might be true about all 4 triangles? They're equal to each other. So I'm going to put A sub T for area of the triangles. Okay. Now there's 4 of them. Agreed? So it's 4 times whatever the area of a triangle is. What is the area of a triangle? 1/2 the base times the height. So what? Take one of these triangles. Doesn't matter which one. Which one is the base and the height?
B and A.
B and A, right? So I'm just going to put AB. Is that all right? So now we're getting somewhere. We're going to use this, and we're actually fairly close to figuring out why is it A squared plus B squared equals C squared. I know you guys are
2AB.
on the edge of your seats. Can't wait, but we're getting there. So this would be 2AB exactly. So if I go 4 times this, it's 4 times 1/2, or 1/2 of 4 is what? 2, and then it's just AB. All right? So let's put a box around that as well. So now what I'm going to do is I'm going to take the things that are in those boxes, and I'm going to, I'll tell you what, let's do this. So what if I wanted to find the area of the smaller square? Let's do some different color. So I'm just going to kind of shade it in. So that one right there. What if I wanted to find the area of that? Well, you say I already got the area of it. It's C squared. But I want the area in terms of the big square and the triangles. So if I knew the area of the big square, which I do, right? Let's just pretend we didn't know this was C. All right? Is that all right? So I know the area of the big triangle is this thing right here. I know the area of all 4 triangles. Did I say triangle for this? I meant square, I'm sorry. Okay, so I know the area of the big square, okay, is this. I know the area of all four triangles. What could I do with those two things in order to find the area of this square? Subtract the triangles from the big square. Exactly right. Okay? So, let's do that. So what I'm going to do is I'm going to take the big square. I tell you what. Let's just write this. The area of the small square is equal to the area of the big square minus what? The area of the four triangles. Everybody see that? So the area of the small square, this right here, okay, if I took it away, if I took the triangles away from the big square, what am I left with? The small square. Everybody sees that, right? Okay, so if I take the big square and I take away the triangles, what am I left with? The small square. All right, so let's put our little formulas in here and let's see what happens. The area of the small square is what? Up here in my boxes. What is the area of the small square? C squared. Okay. There's my c squared, right? Remember, a squared plus b squared equals c squared. So let's do the area of the big one. What's the area of the big one?
A
squared plus 2ab plus b squared. Now what do? Minus the area of the four triangles, because I'm taking the four triangles away from the big square, and I should have whatever the area of the smaller square is. Because it's just c times c. But the area of a square is just the length times the width. Just one length times one width. Okay? All right, let's continue. So this is the area of the big square minus the area of the triangles. What's the area of the triangles? It's in a box. It's in a box. 2AB. Everybody with me?
Yeah.
Okay, so now, watch. This is where the magic happens. All right? So let's do a little bit of algebra, very little algebra. Let's simplify this right side right here, and then once we do that, we're going to see the Pythagorean theorem. So what do we do? So look, 2AB, positive 2AB minus 2AB is what?
Nothing.
It's 0. It's 0. It's not nothing. It's 0. Okay? So look what I have. I have c squared equals what? A squared plus b squared. And there is the Pythagorean theorem. So that's one way, it's one method of proving the Pythagorean theorem. I said, what did I say earlier? I said this is something that you're not going to have to do on a homework or on a quiz or a test. Okay, I said that earlier. This is just so that you can see. And I know, believe me, I felt like this too when I was in college. They used to do a lot of these proofs. In high school, I really didn't have classes where they even talked about proofs that much. But in college, they would do things like this, and people would say the same exact thing. Is this going to be on the quiz? Is it going to be on the test? And the professor, just like I am right now, will get frustrated and say, no, it's just good for you to know. It's good for you to learn. And now that I'm a teacher, I agree with him. I think it's very good to see where this came from. Now, if this was a, I don't know, there's a couple people in my CP class that would appreciate this. I know that, oh my gosh, I'm blanking on his name.
Larry?
Montgomery. What's the younger Montgomery? Trent Montgomery. So Trent Montgomery, he loves this kind of stuff. And he'd be flipping out after he saw this. He would say, wow, that's so cool. All right. But the other people would be doing like some of you guys are doing, have your heads on the desk and not paying attention. But anyway. So, all right. So that's the Pythagorean theorem. So what we're going to do is we are going to do a little example. But I'm going to show you one more thing. We have a thing called this. It's called the Pythagorean. Don't encourage him. That wasn't that funny.
No, you're not.
It's called the Pythagorean triples. Let me show you.
Is it a's to the second?
No. So everybody watch. Here's the easiest one, the most basic one that you're going to see a lot. This is probably off the screen, isn't it? Okay.
No way.
Here's the most basic Pythagorean triple, right? If that side is 3 and this side is 4, let's do the Pythagorean theorem very quickly to find what this is. And we even mentioned this earlier in the year. I've talked about this before. I think we might even had something like this on a quiz, right? Or a test. All right, so let's do it. So C is the hypotenuse, right? So I'll call it C. So let's do it. So C squared equals A squared plus B squared. What's the A? In fact, it doesn't really matter which one is the A or the B. Just one of them is the A, one of them is the B. So I always like to go to the smaller one first, but you could put the 4 there if you wanted to. So it's 3 squared plus 4 squared. Let's do the math. So C squared equals, what's that? 9 plus 16. So C squared equals, what's that? 25. Now, we got C squared equals. I want to find what C is equal to. We've talked about this. We take the square root, okay? So we take the square root because the square root cancels out the square. So now I'm left with C equals, what's the square root of 25? It's just 5. So this is my first. It's the easiest. It's probably one of the most common ones that you're going to see, and it's called a 3, 4, 5 triangle. Not every time are you going to get a nice whole number here, okay? We're gonna talk about a few of those. So not every time you're going to get whole numbers for all of this. In fact, most of the time you'll probably get this to come out to some square root thing. So like, I'm just going to make something up off the top of my head. So what if this was 2 and this was 3? Is this a 2, 3, 4 triangle? Okay, no, because it doesn't work. Let's see if we can do this in our head. Okay, give me a sec. Let's do this in our head. This is 2 squared, which is 4, plus 3 squared, which is 9, which is 13. Then you take the square root. So what's this hypotenuse? It's the square root of 13. Okay, which is what? It's like 3 point something. How do I know off the top of my head? Is it because I'm super smart? I'm absolutely not. Okay, because the square root of 9 is 3. The square root of 16 is 4. So the 13 lies between 9 and 16. Agreed? So it's around 3 point something. All right? But most of the time, most of the time, when you do this, you're probably going to get square roots. All right? But there are times when you're going to get these nice whole numbers for all 3 sides. That's when we call it a Pythagorean triple. Okay? Everybody with me?
Yes, sir.
There are some offshoots of the 3, 4, 5 triangle. Like if I said you had, let's say you had a right triangle, one of the sides was 6, the other was 8, or one of the legs, let's say this. One of the legs, this is not a minus, these are just dashes, okay? So what if I had, one side was 6 of a right triangle, another leg, I should say legs, not just sides. One leg was 6, one was 8. You should be able to tell me, without having to go through that whole entire Pythagorean theorem, what the third side is going to be, what the hypotenuse is going to be. It's going to be 10. How'd you get that? Because you recognized that this is twice 3, this is twice 4, so this is going to be what? 2 times 5, which is 10. You could put that in your calculator, okay, or you could do it yourself. Let's just do it in our head. So this is my A, my B, all right? So this is 6 squared, which is 36. 8 squared is 64. What's 36 plus 64? I'll help you out. It's 100. So what's the square root of 100? It's 10. So does that work? Absolutely. Okay. What if I had 9 and 12? What's this going to be? 15. Because 3 times 3 is 9. 4 times 3 is 12. So 5 times 3 is what? 15. So you could keep doing with multiple things. Yeah.
Is this Pythagorean triple just carried on triangles?
It's only on right triangles because it's Pythagorean. All right, so the Pythagorean theorem only works with right triangles. It doesn't work with any other kind of triangle. It has to be a right triangle. Everybody hear me on this? It has to be a right triangle. Okay, there are some other. Now these right here are just offshoots of the 3, 4, 5. So really, all of these would be considered a 3, 4, 5 triangle. Okay, they're just bigger. They're just bigger in size. Okay, the angles are going to be equal and all that kind of stuff. In fact, later on in Algebra 2, maybe, possibly in this class at the end of the year, we could actually find out what the angles of that triangle. So if this is 3 and this is 4, there is a way to figure out what that angle is and what that angle is. But we're going to use a thing called trigonometry, where we shorten it to trig. Okay? We should get to it. I'm going to do everything I can to make sure we do a little bit of trig at the end of the year. Okay? All right. Here's some other triples. They're not really associated with the 3, 4, 5, but here's some other Pythagorean triples. And I remember a few of them. Sometimes I forget. There's a 5, 12, 13 right triangle. There's an 8, 15, 17 right triangle. And then one more is a 7, 24, 25 right triangle. These are all right triangles, every single one of these. Now, why would you want to learn them? Well, one reason that you might want to learn them is because when you take the SAT, I don't know if they do it on the regular like achievement test that you take, I don't know what they call them nowadays, but whatever the achievement test is that you take. But when you take the SATs, there's going to be times where instead of going through this, watch, instead of going 8 squared plus 15 squared equals c squared, and instead of doing all that on your calculator and figuring out what c is, if you just recognize, like if they didn't tell you this was 17, okay, and they asked you what is the hypotenuse, if you know some of your Pythagorean triples off the top of your head, it's 8, 15, what would the next one be? It would be 17, okay? You could do this, but it takes you some time, doesn't it, to go through this. If you can memorize some of your Pythagorean triples, that can help you out when you take an achievement test because you're timed for those things, especially the SAT, right? They're timed and you want to finish as quickly as, or you want to be able to have enough time to do other problems instead of having to go through all this because you could do this without memorizing it. They probably wouldn't give you really big ones like this, but sometimes they will. I mean, this is very popular. Okay, you see that from time to time. For instance, if they said that one of the sides was 7 and the hypotenuse was 25, and they asked you to find b right here, if you memorize this triple, absolutely, it's 24. How would you do this if you didn't memorize the triple? Well, you put it into the formula, right? A squared, which is 7, plus b squared, which we don't know, equals what? C squared, which is 25. Anybody got a calculator out on them? 25 squared, I should know that. 625 or something like that, I think.
Be quiet and say it.
Quickly.
625.
625, I was right. So this is 49.
Wasn't that far off?
625. Okay, subtract 49 from that.
576.
576. Whoops. Okay, so that's b squared. So take the square root of 576. Hopefully, it's 24.
It's 24.
It's 24. Okay? So look, instead of going through all this right here, if you memorize your triples and you see something like this, and they give you one side is 7, or one leg is 7, and the hypotenuse is 25, then you should just be able to look at it and say, oh yeah, that's one of my triples. It's 7, 24, 25. All right? But you could always go through this and work it out that way. All right, well, we didn't quite finish today. So I'll tell you what the homework, I'm not sure what we'll do. Here's what the homework is. I doubt you'll be able to do all of these, but you might be able to do some of them, okay? So do what you can. We'll call this part A because I'm going to give you another part tomorrow. So it's pages 314. Make sure you write this down because I didn't give you a lesson plan thing today. 13 to 19. All right, so that's the homework. Do as many as you can. We'll finish it up tomorrow. We'll take a quiz tomorrow, then we'll finish up this thing tomorrow. So the quiz is going to be over 7-1 and 7-2. And that is tomorrow. All right.